Everyone, welcome back to another video from Winter Forest. Let's continue our leetcode challenge. Today's question is called what a search tool. You will given 2D board, so it is a 2D array and contain characters. And you also will be given array of a word, so also contain characters. And you're going to search if this word, each inside this array of words is contain one different word, you need going to search. Use this word, go you board, see if you could find a match. If find, you output it. In this question, we're going to use a new data structure. It's called a tree. So first we need to build this. We change this array to build this to a tree. Then we do DFS search. We're going to loop in this board, see if we can find it. If we search we could find, then we just return it. First, for what is the tree, they have a Wikipedia, you could study it. And basically, so if you are coming the word, then we just, the root always empty, so you're going to continue insert, and you have the order of them. Then you're going to, first if you're going to insert the 2, so you're looping for the T, and you insert the T, and then you find the O, then you insert the O, then you have the 2. And if you insert the A, just insert the A. Then if you insert the T, TE, you first check if it exists or not. If it already exists, then you don't need to just move to here. Then you move to next character, E. E haven't inserted before, then you just insert in here. Then because it's T, then you need to insert the A, then the A insert in here. And let's look in here, and they have the pseudocode how to insert and find and load, and also for sort. And we use this one, draw our tree, for you understand it. So we're going to have a tree. So the tree nodes start with empty. Then we have the OATH to insert. My pointer is in here. Then you're going to see if O in this tree node or not. So we're going to insert the O. Now you move this pointer to the A. If the A you didn't find it exist, you see you looping for the tree haven't existed, then you insert the A, then you have OA. And then move on, you carry in, then you have a T. And now the last words, then OATH. You give this tree, this tree the word. Once you insert the finish one, then you insert the second one, PEA. P, we're going to find that the P doesn't exist yet. Then we can insert the P. Then we see after P we have E or not. We don't have, we're going to insert the E. After the PE, then we need a search, see if we could find the A. No, then we insert the PEA. And then move on to another word. It is eat. After you find the eat, then you also do the same, because in the root you cannot find the E, just insert in here. Then you carry on the A, you have EA, and then you insert, then EAT. and then the last word is the same. Once we have this tree, then we going to do DFS search in this board. See if this word inside this one. Also for build this tree, you actually since I only have a character, we know the character only have a 26 character, so we are also just use 26 character. So the maximum nodes the length is 26. Here just let's start coding. So we're going to have the answer is a list string is our result. Now we need to build the tree. Once we build the tree, we return the root. Every time we do this board search, we go into DFS, start search. We're going to have this. These are the words we are passed in. Like I said, we first need to build the tree. Once build the tree, we're going to do DFS search. Once the search finished, each time search we push the answer into the result, then we could return the result. And now in here we need to build a tree. So now we just add our method to build the tree. The tree returned it is called tree node. You see, they are linked tree node. So we actually also need a class for define this type. It is tree node. The tree node will accept this one string. And since we haven't had this class, so we're going to define a tree nodes class. These tree nodes we are holding, you see, this how many? This list array of tree nodes. Each time pointed to, we all have, this one definitely have a next, but the next contain a list of a character. So we just use a tree node. The max length is 26. Because this 26 character, then you just use, and each time you search, you see you have this is the word. We have the word is string, so we have the word. Now we start to build our tree node. Just like what I did in here, we just loop in and push the in. So we have the root. First we new empty tree node. Then we start for publish the legs. Now we have the word, we just loop in and build this tree. This word contains list of string. So each string is a word, W initial for the word, and for each word we insert a character by character. Each word this is a load. We start from the root. We we insert each one character by character. See, since this is an array, we just match the index with this one. You see, if each character, then minus the character, then insert into this value. If it's A, then will be in the index A. See, so somebody just use hash map, but in here since they only have a 26 character, so we just use this character minus A, then match this index. Started with a 0. So if so we have a 20, 25 up to the mark. Until we finish, we give this vote. Now the tree is built. This whole thing here and here just build this tree. The tree is built. Now we're going to do DFS search on this board. See if we could find these words. This tree have the words, and inside this board. So now we're going to start. Since it's two-dimensional way, so we have a for loop and with the nested loop. And we just do DFS search. We give the board. Because each word we did search the board. And we give the position I and J we are started. And we give the root node. And also the result, if we find it, we just push into here. Now we just write this DFS search function. Since we passed this result, so we won't going to return. So we actually just push into the result. So this is void. This board passed in. Just copy paste. Then we have the position where our started. Then we have the tried. Just copy. No, not the tried, the tree nodes. And then have this our answer, what we expected. If we found it, we just push the in. So where our started, we start with the board, pick up this character I and J, and this is a little bit like we actually did previous a lot of DFS search. So we're going to just write the code is similar like previous do. So we're going to first check if we visit before, because I'm going to, if I visit it, I change it to a hash, so it definitely can not a character. And also we check the next. This one is not equal to null. This one or p dot, yeah, if this is null, we just means finish, just return. This is the best scenario. P the character. This is the character. Yeah, and now you do p equal to p dot next. So you're going to, since we are pushed in like this one, so you're going to also get the character minus this one, find this index, then you get this word, get the p. If p dot word not equal to null, it means find one. Then you change this word to null, so you won't go into call it again. So this found before, so you don't need to find this again. Otherwise, just do the recursively call yourself, left, right, up, down. So like I said, if I come in visit view, I'll just copy paste in case I type in wrong. If I come in here, first time coming here, we should change this character to sharp, and we also make sure it is not out of bound. So if I greater than 0, we just DFS, use the board, and going to the left, go up. So basically, just firstly you go up, and then you go, then you go left. It's a 4 director. Each time you do 4 director search, but you also just make sure not out of range. Just go you left. Up, left, then you go to the right, go down. Go down is the border length. If you're not familiar with this one, actually, when you did 1 or 2 DFS searching, find this just like a pattern, like a formula in math. This I'm just making sure when I go, this going and going down, going right. When I go right, I make sure not out of range. Once you search the finish, you change the back to the character because you're going to second time search the game. So you do one word search finish, you do multiple words search. So once you search it, you change it to now you next time won't search this one, but you need to change this one back change the character back because you could be another match. And that is for the code. Let's run. Hope I don't have too many syntax issues. Yeah, look, it's fine. Let's submit it. It accepted. Thank you for watching. Bye.